So when I was learning this in school, I can never remember how to do it because it was like a bunch of random steps. So I was messing around with it a bit recently, and I came up with a way that I haven't seen online anywhere else. That it's quite obvious when you think about it, but like I was never shown it, and it just made a lot more sense once I did it this way. So in order to understand it fully, we need to first understand fully what a HCF and an LCM are. So a HCF is a highest common factor. So a factor just means that something divides evenly into something. So for example, 21, we can divide that evenly by 3, because 3 into 21 gives us 7, and equally we can divide 21 by 7 evenly, because that'll give us 3. So the factors of 21, the factors are 3 and 7. And then if we have another number, let's say, I don't know, 70, if we have 70, the factors are obviously 7, 5, and 2. If you divide 70 by 7, 5, and 2, it'll go in evenly. So the factors of 70 are 7, 5, and 2. And it's quite easy to see that the highest factor that they have in common is 7 here. It's quite obvious in this example, but in other examples where there are different powers, and maybe there are more numbers, it's not so obvious, and you need kind of a reliable way to do it. And then lowest common multiple is kind of the opposite. It means what's the number that has both of these numbers as a factor. So obviously these two numbers are going to keep getting bigger and bigger, and we want to know what the smallest number is that has both of these as a factor. And that's a lot harder, because like I guess a common mistake that a lot of people make is they say, oh well, it's going to be 21 times 70, because we can divide this number by 21 and it's chill, and we can also divide it by 70 and it's chill. But in fact, the actual number, this isn't the lowest common multiple. This is a common multiple. It is both divisible by both 21 and 70, but it's not the lowest one. So I'm going to show you a reliable way to kind of figure both of these out. So the main trick, I guess, that we're using is that we need to figure out what we can do. Obviously we can divide this by 21 and 70, but if we want to figure out the lowest thing we can divide it by, it helps if we break this up as much as possible. So I'm going to start from the beginning. Well, I don't actually have to start from the beginning. I already found the factors of it, right? So 21 can be written as 3 times 7, and 70 can be written as 7 times 5 times 2. Now if we want to find the highest common factor of that, well, basically what we have to do is we have to take these two numbers. So we have 3 times 7, which is 21, and we also have 7 times 5 times 2. And for each of these numbers, we have to figure out a number that divides into both of them. So obviously, the biggest number that divides into both of them. So obviously 1 technically divides into both of them, but that's not the biggest number. So we can see if we divide both of them by a 7, that'll go in evenly, because multiplied by 7 divided by 7, that's all good. Multiplied by 7 divided by 7, and you can see we're left with 3 here, and here we're left with 10, so it goes in evenly. I guess a mistake that a lot of people make is like, oh, well, what about the 5, though? The problem is if we have a 5 here, the 7's cancel, the 5 will not cancel out with the 3, so we won't have a whole number here. It'll be a fraction, so it's not a multiple. If you divide 21 by, this is 35, it doesn't go in evenly. So the highest one is 7, because 7's the only one that divides perfectly into both of these, because the 7's will cancel, and nothing else can cancel. So that's the biggest number that will divide into both of them. It's 7. Now for the LCM, we kind of do a similar thing, except we want to find we don't know what the number on the top is, but we know we want that number to be divisible by 3 times 7, and we also want this number to be divisible by 7 times 5 times 2. So for this to go in evenly, obviously we're going to need a 7 on the top to cancel out with the 7's on the bottom. We're also going to need a 3 on the top here to cancel it out. But the thing is, because it's a common multiple, they both need to be the same. So we need to have a 3 on the top here too, because these top numbers have to be the same. It has to be common to both of them. So even though there's no 3 here, we have a 3 on the top because we want it to be divisible by both of them. And then obviously the top also needs to be divisible by 5 and 2, so you have to add in a 5 and a 2 as well to both of them. Again, I know here adding in the 5 and the 2 just makes it bigger, even though it's not cancelling anything, but the reason we have to do it is because we need it from here as well. We need it from here to get rid of the 5 and 2, so then you can see if we were to cancel these out, here we'd get by, we get 5 times 2, which is 10, and if we were to cancel these out, we get by, and by, and then we just have a 3 left. So they do go in evenly, and you can see if we compute this number, so the lowest common multiple is equal to 7 times 3 times 5 times 2. If you put that into a calculator, so that means our lowest common multiple is 210, which is a lot smaller than our estimate up here, which is a mistake that a lot of people make, is they just multiply the two numbers. This is 1,470, which, yeah, that's divisible by 21 and 70, but it's not the smallest number, because if you divide this by 21, obviously you get 10, divided by 17, you get 3, so this is the smallest one. And you can see that we figured it out in an intuitive way. You didn't have to memorize anything. That all made sense. It was all intuitive. So a lot of the way that I learned it was like take the highest power here and take the lowest power here. You don't have to worry about any of that. Just do it this way out, and you'll be able to figure it out, hopefully, if you kind of try to problem solve your way through it. So here's a harder example because it involves powers, okay? So basically the idea is still the same. We want to break these numbers into their prime factors, they're called. So basically we want to break it up into the smallest factors possible. And we can do that by dividing over and over again. So as an example, we see that we can divide this by the number 2 because we want to get prime numbers, although we could technically divide it by whatever we want. It won't matter in the long run. So let's say we just divide it by 4. That'll give us 21 as our answer. That means that 84 is the same as 4 times 21. So you can see that helps us to break it up, and then we can break this 4 into 2 times 2, break this 21 into 7 times 3, and so on. So I want you to keep breaking it up until you get it into as small numbers as possible. So they're all going to be prime numbers, because when they're all prime, we can't divide them anymore, because prime means we can't divide them. Do the same for this, and then you can use this method to figure it out. So this one has powers, it's a little trickier, but I want you to pause the video. If you want to get the most out of this, you need to pause the video and just try it yourself first, and then you can watch to see how I do it. Right, so if we break up 84, as I said, we can divide 84 divided by 4, and we get 21. So we say that 84 is the same as 4 times 21, and we can break that down even further and say it's the same as 2 times 2 instead of 4, times, and then 3 times 7 instead of 21. And we can't break that up anymore. We can't break up 2 because it's prime, we can't break up 3, and we can't break up 7. However, it is easier to write them as powers, so we'll say that's 2 squared times 3 times 7. It's just a bit easier than writing 2 times 2. It helps us see that there's 2 2's more easily. Now if we break this one up, the easiest factor I guess is 100 first. So if we divide that by 100, you have to kind of do long multiplication, or division, sorry, but it's 14 times 100. So then that's the same as 1400. We can write that as 14 times 100. We can break that up a bit more. That's 7 times 2 is 14. 100, the way that I think of breaking it up is 25 times 4, but we can break that up even more. We get 7 times 2 times 5 squared, that is, to break that up a bit more, times 2 squared, and then we can combine the 2's, and we get 7 times 2 cubed times 5 squared. Okay, so now we have them both broken up. Now, to find the HCF, we want to find a number that divides into both of those, the biggest number that divides into both. So we need a number that divides into 2 squared times 3 times 7, divided by something. And then we have 7 times 2 cubed times 5 squared over something. Now, in order to make it divided evenly, they both have 2 squared. So we're going to need, well, we could technically divide both by 2, just 2. However, this isn't the biggest thing we could do, because we can make this a 2 squared. Okay, the reason we can make this a 2 squared is because this will cancel, cool, and then this is 8 divided by 4, it's going to end up going in evenly, so we can divide it by 2 squared because we want a bigger number. So when I was learning it, they said take the lowest power. Here, you're kind of understanding why we're taking the lowest power. It's because that'll divide into the 2 squared, and it will divide into the 2 cubed, and we're still left with the whole number. However, you couldn't make this 2 cubed, because the problem if you made this 2 cubed is that, well, the 2 cubed wouldn't divide into the 2 squared. It obviously doesn't divide into any odd numbers, so we'd run into a fraction here. It wouldn't be a whole number, so it's not a factor. So that's why we're only doing 2 squared. This one has a 7, and this one has a 7, so we can get a 7 into both of them, and that'll divide evenly. Now, we can't do 5 or 3, because this one doesn't have a 3, so if we divide it by a 3, it's going to be a fraction, and this one doesn't have a 5. Therefore, our highest common factor is 2 squared times 7, which is 4 times 7, which is 28. And that's our highest common factor. For our lowest common multiple, remember we're looking the other way around. We want a number that is divisible by both of these. So let's see, we want a number that's divisible by 2 squared times 3 times 7. And it's the lowest one, so we're looking for the smallest numbers here, not the highest ones like up there. And here we're trying to divide by 7 times 2 cubed times 5 squared. Remember, this is just the same as the 84 and the 1400. I'm just writing them as this so we can see how they're broken up, because the problem that we ran into up here is that when we don't break them up, it's hard to see what they're both divisible by. So here, what we can do is we want the lowest number that's divisible by both of these. So obviously, they both have a 2 cubed. Well, this one has a 2 squared, but the thing is we can't just write 2 squared for both, because if we did, well then the 2 cubed isn't going to divide into this 2 squared, so we're going to be left with a number on the bottom, we're going to have a fraction, it's not going to work. And since they have to be common, they both have to be the same, so they both have to be 2 cubed. So this is the reason why the quote-unquote rule is that you take the biggest number for lowest common multiple. And then obviously they're both going to need a 3, because if they didn't have a 3, then this 3 would be left on the bottom, we'd have a fraction. They're both going to need a 7. and that covers both of them. And they're both also going to need a 5 squared. Okay, the reason they both need a 5 squared is because even though this one doesn't have a 5 squared, if we didn't put in a 5 squared, this would be left in the bottom, and it would not divide in evenly, because 5 squared won't go into 7 or 3 or 2 cubed, so we need to add in that 5 squared for that reason. So that's why it helps to break it up, because we know that 5 won't go into any of these, because these are all prime. So that's the advantage of breaking it up into prime numbers. And yeah, now that's all. Now this will definitely go into this, because you can see the 2 squared, they'll cancel, that's fine. We'll be left with a 2 on the top, no fractions. 3's will cancel, 7's will cancel, cool, no fraction. Here, 7's cancel, the 2 cubes cancel, and the 5 squareds cancel, and we're just left with 3 on the top, so we know that goes in evenly. So our LCM is just whatever that big red multiplication is. I'll put it into a calculator. So it's equal to 4,200. That's our lowest common multiple. So there's also a way to do this with Venn diagrams, but I've seen that one on YouTube a lot before, but I haven't seen videos explaining this approach. So I'd encourage you, if you want to understand it more, to look up some videos about the Venn diagram approach, or the rules as well if you want. But I hope this is kind of insightful into what we're actually doing. Whether you're using the Venn diagrams or you're using the rules, it's still not, I was never 100% sure. I could never remember it fully just because I wasn't sure how it was working. So hopefully this video makes it very clear why it's working. So you can look up questions online. You'll be able to find them if you just look up HCF and LCM worksheet or something. You'll find a bunch of numbers you can do it with. And if you have any questions, please do leave a comment.